Hi there viewers, and welcome back to Game Boy and Game Boy Color hacking tutorials. And this time the process will be mostly of hacking Pokemon Gold and Silver, but there will be more Game Boy related stuff while at it. And last time I talked about scripting a little bit, and today we're going to continue with that. And here I made this script for making the fat man in New Bark Town giving you a berry, and it was achieved with this give item command, having two parameters for item number and amount of them. And this command stores feedback in RAM, and whether RAM is set to if RAM is set to 00 after this command, you're not given an item if false command follows that. So you've got to stick to these two together, give item along with if false. And this command also makes the engine continue the script in a new address. So it works like a jump command. If RAM is 00, jump to this address. But yeah, today I've got this plan of showing 3 different scripts to you and how to make them. First, we're going to make a script where you find money on the ground, a certain amount of money, and may either pick it up or not. And next time or next, there will be a script about making a person event act like a trainer. And last, I'm going to make another script, which will be a normal script like this one, and this will make the person even check whether you have Cyndaquil, or Typhlosion with you, and if you do, he will give you charcoal. But if you don't have room for the charcoal, he will tell you that you can come to pick up the charcoal later. And I'm just going to use this same text document for planning of the different scripts if needed. So first, I'm going to actually use that same fat man for all of these scripts. So let's just decompile the script again, and well, first of all, let's make this person event look like a Pokeball. So we change the picture number to match it with 1, and face type to 1, and this will make it face down, which will be the case we want because Pokeballs don't have different facings, only down. And palette should be 0, and it ought to work. And so now let's decompile the script, and we probably want to remove the existing script data because that won't be needed in this hack anymore. So go to the offset, we can see this part here, and it ends with byte 90, which is here, so we can just delete everything here. And then we have another part in B8, which is here, and ends right here. The next part is right here, which is texturing hey take a berry. So let's also take that one out. And last we have your item pocket is full text string, which ends right here. So yeah, I'm just going to put this 90 here because it will tell you, it will tell the game that, well, it will be the ending command for script. So now we have cleared all the existing data. But yeah, so we probably want the person event. Well, let's just think about what we have here. So we need to make the script say something. So we first load font and then print some text. And the reason why I'm putting 2815 as the pointer here is because of this being, well, it points to RAM, and this is below 4000. So it actually points to ROM bank 0, and where it leads is, well, it leads to RAM address shown here, 2815, because this is the same as writing, this code is same as writing 4C1528 in the ROM, and it shows us to write text 0x2815 here, and this points to RAM address 2815. And there we have a certain code for making the person, well, displaying text object event. So this loads object event. You can see how it really works out by checking what's written in ROM memory address 2815 and checking how in-text codes work. But yeah, this is what we want to use for beginning. And here it should say something like player received 500 zenny. And next we want to play some sound. And well, I've got the sound numbers here in my PC, and you can look for these in Skadendoink. I think Coolboyman has posted this exact same list there. But we can use some of these here, or for instance the item sound. So let's just use the item sound. And sound code is just play sound, and we attach the sound number with it. Here you can see that it's actually a 2-byte sound number, but the sound number is like one. This is like 0100, and it's in PKSV language 0001, and it's the same as 0x1. So this is how this language works, because this is also 1528, and it's written as 2815. So 0100 is written as this, which is 0x1. But we can use this item sound, and next we could simply, probably we could also use close text, and it might wait for the sound to be played through before being able to close text. But we can also we can make sure this sound is played through before a text box can be closed, so it looks a bit more professional in the game. And this can be done with one of the 0f codes, and specifically this one. Wait until current sound is finished. And 0f codes are called special. So we use special 0x3a because this is also the same as, well, like I said before, 300 is 03a and 2. It works like this. This is how PKSV language works. And well, after these, well, now it should say player received 500 zeni, a sound is played, and we can close text before the sound is played through. And next, we use give money code, which is here, number 22, and we have 4 parameters following it. First one being either 00 or 01, and we want to use 00 because this account is probably mom's account, so we can either add them to the player itself or mom. We want to add them to player. And next, the amount of money, well, 500. That is O1 F4 or this. So also this one, if you put it in byte form, it would look like this. And now in PKSV language, it should be in different order, because everything is written in the different order with PKSV than what we got in written in the ROM. So it should work if we write this here. I'm not quite sure about it, but it should work. So it should give us 500, 500, and last we could, if we didn't do this, we could simply be talking to the event over and over again. But here we see that the selected person number is 1, and we can use the hide person code for hiding a person event, and that is the same. That is called disappear. So hide person is disappear in PKSV, and instead of writing 0x1 here, we actually need to write 0x3. Because the numbers you see here in this select box, you should use them, or you have to use them as the person numbers, but you also need to add 2 to them. So to 1 you add 2 to get 3, and this would be 4, this would be 2 with the disappear code. And goes also with if we wanted to move this person event, this Pokeball specifically, it would be 7103 XU location. But here we need, well, yeah, 1 is used as 3 here. And last, we have to load the moving sprites in the RAM, and it should work. So let's just try it out. Compiling didn't give us any problems. And these, as you can see, these notes weren't saved anywhere, so it just looks like this now. and PKSV can't look for data for pointers not being in the range of, well, the pointers need to be in a range of 4007 FFF, so it could look for the address they point to, and it doesn't recognize this one, so it shows like this. But it's not pointing to FFFFF, it's pointing to 2515 in RAM. So yeah, here we are, and actually want to visit the house, come back again, and let's just try it out what happens. Now we have 3000, and if I talk to this, well, you can hear the sound, but the certain sound was displayed and the item was given, and now we have 500 more. And now it looks like everything is fine. The script is working the way intended, but if we return to this map, we can see the item ball is still here, and we can pick it up again and gain more money this way. So we're obviously doing something wrong here, and that's what we are doing wrong. It's actually about the person event's flag index and flag bit. So these here stand for whether the item is shown or hidden when the map is entered, and they correspond to certain bit values in RAM. And as you can see here, flags are stored in this RAM area. Yeah. So, well, how do I say this? Currently we have this person's flag index and flag bit as FF, and that is a certain universal bit number value. So, well, first of all, bit number consists of 2 bytes, and Johto map shows these as flag index and flag bit. So for that person event we had those 2 as FFFF, which also happens to be its bit number. So bit number is FFFF for that person event. And well, bit number refers to a bit in RAM. And here we can see that these here on the left, they are RAM addresses. And these on the right, they are bit numbers. So bit number 0000 refers to RAM address D7B7. Bit number 0800 refers to D7B8. 1000 to D7B9, and the list goes on and on. But what you're probably wondering is where, for example, 0100 refers to. Well, it happens to be so that a byte can have any value between 00 and FF, and FF is in binary 1 1 1 1 1 1 1 1. So there are, did I say it right? Yeah. But well, there are 8 bits that each can have the value of 0 or 1. And those 8 bits form a byte. So here we have a 1 byte RAM address, and the first bit referring to that is 0000. But also 0100 refers to that, and so does 0200. 0300 refers to that, 0400, 0500, 0600, and 0700 also refers to that address. Because here we have 8-bit numbers. First, second, then there are third, fourth, fifth, sixth, seventh, and this is the 8-bit number. And all of these refer to RAM address D7B7. And just like that, here 0800, 0900, 0A00, and so on until 0F00 refer to RAM address D7B8. And this is how bit numbers work. So if all of these bits are reset, RAM address D7B7 is written as 0000. And in case all of them are set, so all of their values are 1, then this has the value of FF, which is the biggest byte value. Well, let's just check it out quickly with an example, and I'm going to go through this kind of stuff a bit later. But here we can see that these bit numbers refer to this RAM address, and all of them are set to 0. Because if we have all 8 bits being 0, the hexadecimal number is 00. If we, for example, have 8 bits so that first bit is 1, or, well, this is the highest bit, this is the 8-bit, 7th, 6th, 5th, 4th, 3rd, 2nd, and 1st. So if the highest, so 8-bit, 6-bit, 4-bit, and 2nd bit are being set, byte value will for example be A8 then. But well, you don't have to know about the bit numbers and how they correspond to the bytes written in certain data address just yet. But it's important to know that what kind of bit values or bit numbers you can use and where they modify data. So now that we have this bit number being FFFF, it won't correspond to the bit number table, which we have right here, starting at this RAM address and going on and on until D8, B6. But for example, if you used bit number 4D00 for this person event, which looks like this with Shoto map, and saved it, we can see that 4D00 writes something in D7CO because it's a bit number smaller than 550. So let's try that out, how it works. Now we have that person event's bit number being 4000, and let's just open the memory viewer and go to D7C0 where something should be written. And as you can see, this byte is now 00, meaning that all of the bits modifying, all of the bit numbers modifying this RAM address, so all the bit numbers between 4800 to 4F00 are being set to 0. So that will also mean that this person event here is shown. And when the bit value of a bit number is 1, then the person event will be hidden instead. And now you can see that when we receive the money here, something will be written here. 20. 20 was written into this address because the bit number value of this person event is between 4800 and 4F00. And now if we come back, we can see that person event is not here anymore, because when the map was loaded, the bit number of this person event was checked inside the RAM, or the bit value modified by that bit number was checked inside the RAM, and we can see that the bit value was 1, and so person event was not shown. And why was 20 written here then? Oh, well, this is because 4D being the 6th bit of this, well, the 6th bit being here because, well, 4800 is the first bit number modifying this RAM address, this being the second, third, 4B being the fourth, 4C00 being fifth, and 4D00 being the 6th bit number. And so in binary, we've got, as you can see, we've this byte was set to 00, so all of the bit numbers were originally 0. So basically, the 8th bit was 0, 7th was 0, but now we have 6th as 1, because the bit value was being set to 1 when the person event disappeared. And all of these are 0, so 50 is 0, 40 is 0, 30 is 0, second is 0, and first is 0. And this in hex is 20. This is probably kind of complicated as of now, but basically what this byte here tells is that we have these this byte, this kind of number in binary form. So every bit number sets a bit in a byte. So we've got 8 bit numbers modifying 1 byte, and here when we set the bit used by bit number 4D00, the 6th bit into this RAM address was being set, making the byte written into that address as 0x20, which happens to be 0010000 in binary. And well, I kinda went off the subject already, but as you can see that when a certain person events, well, when the bit value of a bit number is 1, person event is not shown, and if that bit number, bit value of that person event, or if the bit value that bit number points to is 0, then the person event is shown. So now the person event is made hidden, and the bit is being set, so the person event won't be shown anymore, and if that bit is reset, the person event will be there. So yeah, this script worked, and there's nothing more to it. Okay, back from a little pause break, and well, this stuff took a bit longer than I expected, but I'll try to move on faster with parts 2 and 3. But basically, next, we're going to make the fat man being a fisherman. So first, let's edit his person event, and this time we can use FFFF as the flag index, because he doesn't have to be hidden any time. He can be well, yeah, we want him to be shown all the time, so let's just use that as his person event, or flag index and flag bit. And here we have this type, and we want to set the type to true. And this is part of the person's function byte, which I'll be explaining pretty soon. So here in the scripting compendium, we've got this event structure, and for person events, we have a byte called color function byte, and it's split into 2x4 bit values, and the second part of those 4 bits determine what kind of person it is. So it's function byte, whether it's a normal person, whether it's an item, or whether it's a trainer who will challenge you. And we're going to use this trainer function type here. So if it's trainer, its script pointer points to this kind of a structure. So we're not going to use the normal script data for this person event. We have to use a different one. What did just happen? So this is the can I keep that thing opened? Yeah. But this is the kind of structure where the person event script pointer has to point to. And right now it points to ROM address 122582. So let's just delete this code first. I'll write something else here. So first we need a 2-byte bit number. And this time let's for example use 4A00 as its bit number. Next we need trainer group and trainer number. Well, this is also something that are documented in Skentedowing, so go and search for them there. But I have my own list here, so we're going to use this. And Fisherman is trainer group 25, so we need 25 here. And this is followed by its trainer number. So let's for example use, well, we'll check this later what this is. So this can be for instance 0A now. Next we need 2-byte pointer to text when seen. And that could for example be that 1528 pointing the object event. And same for when he's beaten. Next we need 2 bytes for blacking out. Oh, 2 bytes as 0 zeros. They are meaningful here because they need to be that way, but yeah, you just mark them as 0 zeros. And then 2-byte pointer to text, 2-byte pointer to script if 1, or talk to again. And here we are in this address, so we could for example make the script data start right away after this one, these bytes. But we could also put it here instead. So now this script pointer leaves here, and this kind of data that we have here will be normal script data. And if we just want the person even to talk to us after the battle, well, you know how to do that. It's just using the normal scripting instructions. And we could write this data with PKSV as well, but this time I'll just use a hex editor because there's nothing that complicated. But first, if we don't want the person even to talk to us right after the moment we beat him, we put 65 here. And next, that should be continued with the normal script data such as, well, we can for example use code 51 here. Displays the text and lets person turn to hero. Afterwards there's no other script interpreted. So this is the universal script data for most person events who don't do anything else but talk to you and say something. But I don't know why it's programmed to work that way, but trainers will face you after the battle when you talk to them without having a face player code in that script. So we can just use code 52 instead. So it doesn't execute face player twice, which it does after you talk to him. And I don't know why it does that, but it does. So this kind of code here is all we need. And now, if we talk to the person event, we should be battling against this fisherman guy, and the script would end like it should. As you can see, he doesn't challenge us, but this is because his sight range value is set to 0, so he won't see us in front of him like he normally would if that would be something different. And if we talk to him, alright, let's just correct those little things. So formerly I changed this phasing byte to 1, and well, he won't phase when talk to him if that is the case. And let's just use the sight range as 2 as well, and this could be, yeah, let's use that as 1e. And 1e makes him spin around in a certain direction. You can see that now he does this, and if I'm 2 steps away from him, he should challenge me like this. And now a battle would start and would have ended, but we didn't have a Pokemon, so nothing really happened. But here 04 was written in D7C0 because this guy's bit number being 4A00, and that also modified this byte just like 4D00 did. And if this is set to 0 again, he will challenge us, and after the battle the bit value of the bit number is set. And if I wanted just quickly, I could actually challenge him as well. Now he won't challenge us because the bit value is 1, but now that it's 0, he should, or he will. And we're against Fisher Wilton. And that Wilton was picked up from being the 08 fisherman in the game. And if I remember correctly, yeah, this is where the pointer table to trainer data are located. And the first pointer is in this address. And because each pointer is 2 bytes long, we can find the 25th pointer by multiplying 25 minus 1 with 2 and adding that to the start of the list. So adding that to 3993E, and we get 39986, which is here. And this thing points to 7767. That points to 3A777, I think. And now we'll just open a table file. Yeah, we can see that the first fisherman should be Justin. Then we have Ralph, Arnold, Kyle, Henry, Marvis, Chris, Andre, Raymond, Wilton being the 8. Or no, not the 8, but the 08. Well, let's go back to that. No. Well, I'm not going to show you how to do this, but if you wanted to expand this fisherman table to add more fishers to the game, you'd simply copy paste it elsewhere. And yeah, it's probably used with these. We've got these instructions here. Starting from copy from certain address, pasting elsewhere. Then you just fill the original data with 0 zeros and write your own data at the end of the list. But to make you challenge Ralph, you would use that trainer number as 02 because Justin is 01, Arnold is 03, Kyle 04, Henry 05, and so on. But this is how training data works. Well, finally, I will still show you the example about the this third one here I have planned. So basically, let's just turn that fat guy into normal person event again. Change his face type to 3, site range 0, type into 0. And then we open the script here. And this stuff is just shows some leftover data. Over the trainer script. And we can simply now modify this. So I'll first write end here, so we can start rewriting the data in that address where the trainer data or trainer script was located. So first, he obviously needs to face us and tell us something. Or well, let's think about this through before doing anything. So what we need to do, yeah, he has to face us and say something. And he could, for example, tell us that, hey, you have So he could say us that, hey, you have this Pokemon. A person trying this Pokemon should really have use to this item. I sure don't. And that Pokemon there is either Cyndaquil, Guilava, or Typhlosion. Whatever or whichever of them you've got. So before that, to write text. Well, first, obviously he needs to face us and load font to say something. But before telling us that, we need to check whether we have one of those Pokemon, and we should have some kind of check for Pokemon code, I think. Yeah, checks if there's a certain Pokemon in team, gives feedback in team or not in team. So we could, for example, well, yeah, you can see the feedback there well enough. But yeah, we need to check for Pokemon with this command, and as a parameter we need the Pokemon number, and these from that guide happen to be 9B, 9C, and 9D. So that's the three we're going to use. So let's just check for Cyndaquil first. And if Cyndaquil is in team, or if Cyndaquil is in team, we need to check. We can continue to the following script data. So if in team, he should tell us that, hey, you have Pokemon. So this is actually not part of this script. It is part of the, well, it's part of the main script, yeah, but it's part of the main script where we jump to with this command. So if Cyndaquil is in team, we jump to that script, and let's just mark it with this one, so it shouldn't show anything yet, and we just copy that twice. So first we check whether Cyndaquil is in team, then if Guilava is in team, and finally if Typhlosion is in team. And we should jump into 3 different addresses, because relating to that byte, we want the person event to tell us this. So we somehow need to load this Pokemon text string. Or we need to load the name Cyndaquil, Guilava, or Typhlosion somewhere in RAM, which we use with this writeText command. And here now, it first checks whether we have one of these Pokemon, and if we don't have any of them, he could tell us something. He could, for example, tell us that what a nice day it is. Yeah, he could say that, and then the script would just end like this. Or if you happen to get a Cyndaquil, or one of its solutions. Go and show that to me. So that way he would actually tell us that you should do that. And this here is just preliminary planning, and it could work like this in the beginning. So let's just compile this into ROM, and we can see that 0x17 bytes we needed, and so this code should end before 1225B9. But I'm going to put another part of this script where one of these leads a bit farther ahead, because we may need to write something here later on. So let's just put this, for instance, to 1225DO. And this one here could, for example, lead to that. And well, now if we have Cyndaquil, the script continues here. And what these three share in common is the same ending code. They all have this in it, and if we want to make it so that the script continues in the exact same way. So it would be stupid to have three scripts looking exactly the same, except for something in the beginning of them being different, which loads this Pokemon name here. So we need to use a jump code, and this jump code is attached to all of these three, leading to the same ROM address. And before the jump code, we load the Pokemon name somewhere in ROM. And there are these string commands, and we can use this display Pokemon name command. Writes Pokemon name to memory 1, 2, or 3 for later use in text. So it's Poke to text code, I think. And in this case, we need this parameter being 0xb, because we want to load Cyndaquil in that memory address, and let's use that memory address as 0x0. And this thing here takes 6 bytes, so the Gilavas thing can be 6 bytes ahead, and it's the exact same thing except for this value being different, and the same thing goes with Typhlosion. And if you add 6 to 6, you get C in hexadecimal. So this should be the script loaded if you got Typhlosion, should be, or could be in this address. And this also takes 6 bytes, so we could put the next script in 1225E2, where all of these lead. But I'm going to put it, for instance, in 122E5, because you'll never know if you need to expand stuff, so it's good to have some leftover space between them. So now here, if we got one of these Pokemon, the Pokemon name is loaded into memory slot 00, and they all of the main scripts continue in this exact same offset. And here we need some text code for doing that. for saying that, hey, you have Pokemon name, and this can be done with the in-text codes. So we can write text from RAM. So how it goes is that the text data pointer points to 00 like normally. Then you have some data here, and you end that data with byte 50. And that after 50 you can have any other type of in-text following it. And after 50 we need to write 01 for writing text from RAM. And after that we write RAM address. And that RAM address has to be used for memory 1, which is CF91. So we would actually write something like well, the text data should look like this: 00. Then we have this, hey, you have space here, and then we have 50, 01, 01, 91 CF, and then we have 00 following it to start another normal in-text code. So 00 text ending with 50, then we put 01 and RAM address, and you can use another 00 for continuing to write text. And this is how we can make it, say, a text string of this kind. And here we need to use another 50, 01 RAM address 00 and continue the loading the text data. And next you could close text and give you an item. And unlike before, I'm going to use this commented give item code 1D, which comments where player puts what item is in a short monologue, and that is verbose give item code. And charcoal is item number 8A, so we need 0x8A and 0x1 as parameters here. And just like 1F, the feedback is 00 if bag is full. So we check if bag is full, and if it is, the script will continue in some other RAM address and no item is given. And this verbose give item also plays sound, so that's also been built in this command. So a sound is played, and the item is you get a short monologue of the item being placed in the item pocket. And after this, we can make it script end. But instead of doing that, let's use setBit1 command. And this thing here is used for setting a bit of bit table 1 to value 1. And you attach a bit number to this. And if we, for example, wanted to use bit number 4C00, we would write 0x4C here, because that is the same as 0x4. again, the PKSV language works so that this is the same as this, which is the same as this. So now we set a certain bit for making us receive the charcoal, and well, here we could now be checking for bit 0x4c. Checks whether a bit of certain bit table has the value of 0 or 1. And if that value is 0 or 1, well, with if true command, we can check whether ram is not equal to 0, 0. So in this case, if bit value is 1. And from here, we want to script jump to another address where we, for example, make the person tell us that we already received the charcoal. He doesn't have any more to give us. So that could basically lead to a command jump text face player along with 2-byte text parameter, text pointer. And this pretty much works. But if we want to expand it so that he tells us that we can come to pick up the charcoal later, we would have to write another type of script here. So well, let's just compile it like this first, and we can see that this takes 0xf bytes. So we can, for example, put a script here where this lays, because that's 0x10 bytes away. And if we don't have room for this, it could set another bit 0x or bit 4b00, which is this one. And instead of only setting that bit, it could tell us that so now it tells us that we can come to pick up the charcoal later. And so here it's check whether or not so how it works right now is that if we have received the charcoal, it jumps to this address, and this is used for telling us that we got the charcoal already. And this here is used for making us able to receive the charcoal again. And it could lead to a structure similar to this one, but it can't jump straight here, because then it would be using the dialogue for, hey, you have a Pokemon, person training Pokemon should have to use this item. But instead we can make it jump to a kind of structure which makes the person faces, load font, use write text command for telling us, hey, did you come for the charcoal? And then use a jump code for continuing the main script at this address where this close text is located. And it's 3 bytes away from this, so it's at 1225E8. And then it would be checking, it would be giving us the charcoal, and if we don't have room for it, it would say you can come to pick up the charcoal later. And this command here wouldn't do anything because the bit was already set. If we set it again, it won't matter in any way. But if this time we have room for the charcoal, it is added to our inventory, and this bit is set. And after it is set, and you talk to the person event again, it tells us you got the charcoal already. So, as you can see, the things get kind of complicated once you add more and more stuff to the script. But you should do it in pieces. So, I pretty much implemented everything required for not letting him tell us this, because our only thing that would be needed would have to be only thing missing would have to be done is this script loaded for making him tell us that you got the charcoal already. But apart from that, the script should work just fine. But yeah, every time you script, you should do it in pieces and leave a bit of room between the commands, and you can stuff them closer to each other when you have first completed the script and see that it works perfectly. And well, yeah, that's pretty much all about it. And I may come to scripting examples in the next part as well, but I'm not sure yet. There are plenty of tutorials about the things you can do with this kind of stuff, and the only thing I haven't explained that clearly is, well, this map header, map script header. But also this one is explained in the part link to part 4, which is about the scripting compendium, what you can use this for. But yeah, this stuff is pretty much all about knowing how to program, because we're using a programming language built in the built with the original game engine, and it's no way more complicated than this, but you just have to plan out how things is going to work, and then you just write it. And I totally recommend using PKSV, because this kind of stuff gets kinda, well, yeah, it would get too complicated for me if I was doing all this in hex, because that way it's just so hard to follow with everything you do. But yeah, that's pretty much all about it for today. And I'm not sure if I go on with scripting next time, or whether I start assembly examples, but we'll see then.